welcome back to our SPICE program. My name is Claire, and today we are covering Pandas and Numpy. Pandas and Numpy are two of the most commonly used Python libraries for data science. We'll go over what are libraries, how to use them, and then some basics for Pandas and Numpy. And so what are Python libraries? So Python libraries can be thought of as a collection of modules that extend the functionality of Python. What's really nice about Python as a language is that it has a really large open source community. And so there's just a variety of developers who've created libraries with really specific uses. And so we'll be going over how to install these libraries and how to use them. And so for installing libraries, you just need to, at the very beginning of your code, or technically anywhere in your code, but people, for cleanliness standards, put them on the top of their code. You write the syntax as import and then the library that you want to add. So in this cell, we are importing Numpy, and you can have shorthands or nicknames by using as and then whatever is the nickname that you want for your library. You don't need to do this, it's just so for when you're calling the library, you can just use like np.the method instead of numpy.the method. It's just for saving typing. So many of the libraries that we'll cover are already pre-downloaded on your computer along with Python because they're so commonly used. But for less used libraries, you'll actually have to install them to your computer before you're able to import it into your code. So for installing packages, you can use either pip or conda. Please note that you can only use conda if you've already downloaded Anaconda, which is a package manager and environment for Python. I go over Anaconda in the bonus material, or you can also just look it up. It's very useful. And so by default, pip is the package manager for Python. So in the terminal, if a library is not pre-installed, you need to type pip install and then whatever the library is that you're trying to install. For example, you can do pip install opencv for Python's computer vision library. And so once you've done that, it will be installed to your computer along with your instance of Python. And so then you can go back and in your script say import whatever that library is. So back to our example, it would be import opencv. In terms of this notebook, any terminal command needs to begin with an exclamation point. That's just how Python notebooks work. But normally when you're using a script, you are going to type this command actually in your computer terminal and then writing the import statement in your code. So first we'll get started with talking about Pandas. So Pandas has its own data structures separate from Python. And these are really, really commonly used in data science. So they have both series and a data frame. So a series is just a one-dimensional object that is really similar to a list. Mainly we'll talk about data frames because data frames are superly commonly used for a variety of data science-based things. So data frames can be thought as a two-dimensional NumPy array or a collection of series. It's basically a matrix. I have this really large graphic kind of showing you the anatomy of a data frame. So you'll have a matrix, and it'll have a row name and column names, and these act as your indices, and then you have the matrix of values. And so these Python series, not Python series, but these Pandas series are collections of either the columns or rows. So we'll go through an example of actually creating a data frame by reading it from a CSV file. This will be kind of closer to what you'll be doing if you want to perform some data analysis. So this command just downloads this text file from where it's hosted online on GitHub. And now it's loaded in our Colab environment. Usually if you're running this like locally or on like a lab server, you wouldn't need to do this because the file you're referencing is hosted actually on that computer. And so here we're actually reading in that text file using this Pandas method called readCV. This is a super useful method. I use it like all the time. And so what it does is that it instantly converts your data that is from a file, like a CSV file or a text file, and it's immediately converting it to a data frame. And so we're using this method.head just to give you the first 5 rows to give you a sense of the idea of what kind of data that we're storing. And so we have our columns that are cell surface area, dendrite type, wheelbase, input resistance, and tau, and have the rows that are just numerically counted for the number of different cells that we have. Here we have like the data, the different observations of our data in detail. And as I said before, each row is just a different cell that is recorded and measured. And so we'll go in on how to actually manipulate this data after we've loaded it in. And so similar to dictionaries that we've spoken before, you can access data frames by their names, so specifically their row label and their column label. And so to index an individual column, say you wanted to like take the cell averaging, or for the cell, like averaging the cell surface area or something like that, we would just call the individual cell surface area. And then similar idea to index a row, we're using the lock command and putting in the row label. And then to go through by the different index number, we would be using the ilock command and then the index number. So here is kind of a variety of different examples for how to actually read through the data frame. So here we're just going by column, specifically by the cell surface area. Take a moment and maybe try different column names to see what output that you get. Currently, we have just the reported cell surface area for each of the different cells. Here is an example for a single row. We're just doing the first row. Remember that Python starts counting by 0 and not 1, so 0 is our first row. And so we can see for our first cell what are the different statistics for that cell. And then for if we want to, say, just get the cell surface area of the first cell, we would index similarly as we talked about for lists. We would get this first data point of the first cell, which is this 542 value. So that is kind of the workflow for reading through a data frame. So maybe we don't just want to go through different columns or different indices of a data frame. Sometimes going back to the conditionals, we want to look up and subset our data frame by, say, a specific type. And so here we're doing a conditional to filter through what data frames that we want to look at to creating a new data frames. In this context, we're saying as spiny cells with the dendrite type spiny. And so here we're again taking the conditional, making sure that we're only filtering for this dendrite type to create our new data frame that only consists of this dendrite type. In this way, we can later use these data frames for like comparative methods. So maybe we only want to see the average of this dendrite type and compare it to the averages of another dendrite type, and to compare how these two different types might differ. And so we kind of covered some of the really commonly used methods for data frames, but Pandas has like a vast amount of methods for data frames, so I recommend that you look at the user guide to look at the documentations of different methods. Here, where it will immediately calculate some basic statistics for the different columns in our data frame just by using this method .describe. You can see how this is a super useful library for doing initial analyses on your data. Here, give a try on actually plotting two metrics from the data. You can see how they are correlated by just running this command plot.scatter. Make sure that you import the matplotlib library before trying to do this, and then reference the scatter documentation for actually how to use the scatter method. So try plotting your data here. Here we'll briefly talk about Numpy. So Numpy is commonly used for arrays. They're called Numpy arrays. They're similar to Python lists, but have their own methods specifically made for data analysis. And so here is just a instance of the difference between a list and a Numpy array. So they have a different data type and it will be specified. So instead of being specified as type list, it has data type numpy.nd array. And so we'll go into an example of how to use NumPy arrays for data analysis. And so we have this CSV that's formatted similar to this of different EEG values. I took the EEG data here and I made it into a CSV file by just copying and pasting it. And you can upload your files to Google Colab by clicking this folder icon and clicking this upload button. You can see here that I have the information file here. And so by clicking this, we're using the np.loadText method to read in our CSV and having it save as a variable called data, which is a NumPy array. NumPy has a lot of different statistical methods that we can use. So for example, here we can get the overall mean of our data by just using np.mean. NumPy has a lot of other different functions for descriptive statistics. So over here, give a try on using the min, max, and standard deviation methods. here. When analyzing this data, we might want to look at more specific values than just having our whole NP array. And so you can subset NP arrays similarly to Python lists, but NP arrays are two-dimensional. So we have the index for the first dimension, which is the rows, and then the second dimension for the columns. In this example, we're going by the first row and then all of the columns. And so this the semicolon is for saying that you want the whole column and not just like a specific index. If we wanted a specific index to say only the first column, we would just have 0, 0. But since in this case we want the whole second column, we're just going to use the semicolon. And so here we can see that we can calculate the max inflammation for the initial patient as 18 by using the np.max. But what if we want to see the maximum inflammation or the mean inflammation over the course of days instead of just having this single data point? And so we can do this by going along a particular axis. So axes are because NumPy arrays tend to be two-dimensional with columns and rows. 0 signifies that we're going to perform this operation across the rows. If I wanted to do columns, then I would put 1. So then we're performing np.mean across all of the rows instead of for a single data point. So now we have means across a patient over the course of days. We can see the shape of this NumPy array. And so what shape does is that it tells you the dimensions of this matrix. And so we can see that this is 40 comma blank, so that means that we only have a 1D vector that is 40 data points long. And so this is important to keep track of what your shapes are, because NumPy array methods usually expect certain shape dimensions, and so this gives you a sense of what dimension your data looks like. So again, if it's blank for the second dimension, then it is a vector where you only have 40 rows and 1 column. Here we're printing by the columns instead. So here we get some of the averages along the columns instead. And so this would be the average inflammation per day for all of our patients. So that's the kind of the basics for Pandas and NumPy. Thank you for following along through my little Python tutorial, and I hope that it's helped you prepare for ideas for your upcoming projects.